Before we talk about logs, can you tell me everything you know about properties of
exponential functions. Sorry, I was on top. They go. Oh,
Let's do
they
properties
5, 3, 1, 0.
of exponents. Let's think about what we know. Go ahead, Cormac.
They always go through 1, 0.
Huh?
They always go through 1, 0.
Oh, okay. So if we graph an
or 0, 1, 0, 1, 0.
if we graph an exponential function,
Yeah.
it's always going to go. It's always going to go through 0, 1.
Yeah, that's what I was saying.
That's the graphical interpretation. Yeah. So they always go through 0, 1. And then as long as we're looking at the graph, what other feature does this have?
It always
Finn?
The curves.
It grows exponentially. Ella?
it has horizontal asymptote of 0.
So they all do, right? Okay. Can you tell me some algebraic properties? And, I mean, if you see something else on the graph, you can tell me. But what other algebraic properties do we know about exponents?
They approach 0 on one end, they approach infinity on the other.
Yeah. So as x approaches negative infinity,
So it means like they all
y approaches what?
they all have like horizontal asymptote.
Yeah. So we said that they all have horizontal asymptote. Y approaches what?
0.
And as x approaches infinity, y approaches infinity. This is true when?
When the base of the exponential function is greater than 1.
So this is when, let's say if we say a is greater than 1, in f of x equals a. So it could be the base, or it could be the coefficient. So you want the base. So like we're talking about different bases here for f. So when a is greater than 1, what about when a is less than 1? Do you remember from graphing?
It becomes, it essentially vertically shrinks, but it still does approach.
I think we should go back to Desmos. So can you fill this in? Fill this in now if you can, or after we look at Desmos real quick. So I'd like you to fill in the two squares. Can you close your book, please?
Can I use it to follow along? Because I'm a little confused.
No, you can follow along and you can ask questions in class. What do you think? Cormac, close your laptop.
Yeah,
All right, so let's put in some different bases. I'm gonna use a in Desmos as well. So let's do y equals a to the x. And I'll make a slider. What does it mean when a is 1?
1 to the x.
It's just line. It's just the line is y equals 1 at all times. It's not really an exponential function because it just simplifies to what? It's just 1. So it doesn't have the asymptote y equals 0, right? Do you agree?
Yeah.
What asymptote does it have?
Nothing.
Nothing. It doesn't have
Y
that.
equals 1.
It will never approach anything. It's just gonna be 1.
So it depends on what your definition of asymptote is. Kind of like you could say
y equals
it's-
0.99999.
no, it doesn't have to approach. So y equals 1 is just a line. So it's always y equals 1. So that's why in exponents we don't allow the base to be 1 because it doesn't have the same properties. So if a is greater than 1, then it has this sort of positive aspect, right? And these. Do you agree these all have y equals 0 as an asymptote?
Yeah.
And it all passes through 0, 1.
Yes.
And as x goes to infinity, what is y approaching? Infinity. Yes. Right. Okay. And then if I go less than 1,
It's opposite.
does it still have y equals 0 as an asymptote?
Yes.
But then as x approaches negative infinity, y is approaching what?
Infinity.
Positive infinity.
And as x approaches infinity, Baron, what is y approaching?
Infinity. Or x approaches infinity, then y approaches 0.
Yep. So we have enough to fill in the rest of our.
Less than 0.
You want to see less than 0?
Yeah. Okay, it just disappears.
Wait, so it becomes x to
Imaginary.
infinity, y to 0, x to negative infinity, y to negative infinity, or x to negative infinity.
So which one? You talking about for when a is less than 0?
Yeah, I figured
Uh,
out
less
how
than-
to
less-
imagine the graph.
Yeah, less than. Yeah, you just have to imagine the graph. This is the easiest way to think about that. Graph it by hand or imagine the graph.
Whoa.
All right.
You found your apple pencil.
So what do I need here?
Infinity and then 0.
Y approaches infinity and y approaches. Is it infinity or 0?
Infinity is the
Infinity the first one, and 0 here.
0.
Right. Yeah. So, what about algebraic properties of exponents? So this is all true. This is for like a single base or a single expression, if I graph a single expression. But what if I have like a to the 2 times a to the 3?
Then you add the two.
I see a hand. I'm going to call on the hand first.
8 to the 5.
It's a to the 5 based on what property?
Adding the exponents property.
Yeah. So if I have some x here and I have some exponent here and I multiply it by some exponent here, what do I get?
X, A plus B.
X to the a plus b.
X to the a plus b. Okay. Can we think of another property? So this is graphically this is kind of true of one function of x, but then as far as listing properties of exponents, this is kind of the stuff that I'm thinking of.
I have all of them over here.
Well, I don't want you to look up. I don't want you to look up on a chart. I want you to think about it and remember things.
I'll think about it. I've thunked.
What have you thought?
XA over XB is equivalent to X to the A minus the B.
Does that make sense? Okay. You got another one? Patrick, you can think of one?
Yeah. I can
What you
do
got?
so, but x to the a, make parentheses to the b equals x.
Wait. Before you tell us the answer, can everyone write down what this is? Can everyone write down what this is? Write it down. Yeah. Yeah, I see that. Yeah. A inside the parentheses, yeah.
This is also a part of the final exam, like the problems.
This is all.
Did you
going
write
to
down
be
the
on
properties? We're making a list of properties. Are you making the list?
Yes.
Jacob's
Oh,
fine?
glad to.
You find out?
It's not even nice.
No, bro.
Wait, Mr.
Oh, bro.
I fixed interest.
Why is it though? Do we have an understanding of why that
Because,
is?
dude, so if you think about it, right, like, wait, let me, so like, you got the thing, and then you're counting it again, like,
So if I have x,
Very descriptive.
if I have
font.
x cubed, and I have 4 of them, what's another way of writing that?
X cubed times x cubed.
X cubed times x cubed times x cubed times x cubed. That is x to the 3 plus 3 plus 3 plus 3, which is x to the 12, which is the same thing as doing what?
X to the
To
3
the
times.
3
X
times
to
4.
the 3 times 4 equals x to the 12.
Crazy.
Right.
It's like in the exponents, it's 1 degree of it's 1 degree of addition lower, because addition the multiplication.
That's the way I think about it too.
Exponents and the thing above exponents and the thing above that.
Yes, that's how I think about it
It
too.
just moves down.
That's how I think about it too.
Wait, what's the
If you're
exponential?
exponenting an exponent, so it's multiplication.
So this
When you
exponent
multiply
turns into multiplication.
It's addition.
This multiplication turns into addition.
Yeah.
This division turns into subtraction. And then do we have another one?
Inverse multiplication.
Yeah, well now there should be an A
Would
divided
become
by B,
division.
right?
Yeah, so maybe it's a to the 1 over b.
X, A.
What would that be?
That'd be 1 over x to the AB.
Right.
Or X to the A over B? Would that work? Or
No, x to the AB. Which equal 1 over x to the AB.
Is that okay?
Beautiful.
And then go ahead and look at your list, Ella. Are we forgetting any?
Yeah.
Zero.
Exponent
Just
Exponent of 0
like,
is
zero is
1.
There's also the bars.
The what?
Yeah, but those ones aren't important. A over B all to the m.
Yeah. Right. So this is an important one. So x to the a over b. To the a over b.
No, it's just like it would be like x over y to the a or something.
I see.
Equals x to the a over y to
Can we
the
also
a.
do the x to the a over b?
Yeah.
Which is equal.
What is this?
A to the power of m divided by b to the power of m.
Mm-hmm.
Whoa.
And then what's the other one, Cormac?
The x a over b.
X a over b equals a over the x to the b to the a.
We probably don't need that.
What do you want to do with this?
So it will become like a square root.
It is x to the a under root b.
You agree with that?
No.
Looks about right.
You don't agree with this? Is a over b equal to a
Well-
times 1 over b?
The properties of radicals one, it says like a to the m on the nth root would be a to the m
Like this?
over n. Yes.
Yeah, it's the
Yeah.
same thing.
A to the n.
Mm-hmm.
Yeah.
1 over something is the same as that something
Yeah, but it's
root
much
of the
more
number.
clearer.
Yeah, so this means the bth root. So this is the bth root of x to the a. So these are saying the same thing.
You can also write it as the bth root of x all to the a, and it results in the exact same answer.
Mm-hmm. Right, because a over b is also equal to 1 over b times a. So I could say this also equals the bth root of x to the a,
That's
right?
what radical said.
All right. Why did we take this trip down memory lane for exponents?
Because it's useful to remember and probably relates to something we're about to learn.
Because
Probably does.
exponents are the opposite of logarithms. So like the logarithms have similar things, but it's like not the same.
Okay, so I'm gonna name some properties. Like what properties do we already know?
Everything.
What kind of property?
We
Of
knew
logs.
everything already.
Properties of
We didn't
logs.
learn anything
I'm
else.
lost in the sauce.
Log a to the or to one or of one of one, yeah, equals 0.
Log base a of 1 is what?
0.
0. It's a to the power of 0 and it is 1.
0.
All right, you got another property?
Log base a to the a equals 1.
It's not to the. It's not to the.
Log base a of a
Log base a of a
equals 1.
equals 1. We have other properties? Yeah.
Log base a of a to the x equals x.
Mm-hmm.
If log base
This is really a special case of this, because this
It's
is
a to the 1.
this is true in general. Yeah. So if I
And
just
the
let
top,
x.
it's all, the top one's also a case of that because it's a to the 0 equals 1.
Right. Yeah, so I could say log
Lag.
log base a of 1 is also log base a of a to the 0, because that's the same as 1, and that's 0.
Because 0 is the same as 1.
So these are both special cases of this.
Wait, 0
You agree?
is the same as 1?
No, I
log
was
base
just.
a of x equals log base a of y, then x equals y.
Wait, for the second one,
Yeah,
what's
0
that?
equals
What's
1
it?
actually.
A to the what?
1. It has an implied exponent of 1. Did you follow, Matt? Did you follow this one?
What do you mean?
Did you follow what we were just saying?
I wrote it down.
I didn't ask if you were down. Did you follow it? Do you understand it?
Yeah.
Hmm?
Can you say it in your own words?
So,
Log base a of a. to
Finn,
the 0.
I don't need your help. So, what's a way of rewriting this in terms of base A?
Log base a of a to the 0.
A to the 0. A to the 0 is equivalent to 1.
Yeah.
And then because of this property, where I'm canceling out the log base A of a to the something, and I just get the original thing back, I can cancel these out and get 0 back. Yeah. All right, so that's a kind of review of some of the stuff we know. We also know log base. What's the log base formula?
What about natural logarithms?
So these are all true for natural logs, and they're all true for log base 10. This is log base A in general.
Yeah.
So if you what's the equivalent? This is base A. What's base E?
ln
Log e.
Ln of
1
1
equals 0.
equals 0. What about base 10?
Log 1
1
1.
Log base 10 of 1 equals 0. What about this next one?
Log base
Ln
A.
natural
A.
log of
equals
0.
1.
A.
No, e.
Ln E.
Oh,
Ln E.
E,
Thank
right.
you. Equals
1.
Uno.
1 or 0.
Uno.
1
And then this is log of
10.
10 equals
Log base 10 of 10 equals 1.
1.
right. And I don't have to write the 10 here, right?
Wow.
And then what about this? What about this one?
Log
Ln
ln
or
e
ln
of x or
e to the x.
equals x.
Nice. And
Log base or log 10 to the x equals x.
amazing.
Look at that.
Amazing.
And we also have
Log change of
Yeah.
base.
If
Log
ln
base A,
x
x
equals
equals
ln
Oh,
Yes.
if yes.
if
If log base A of x in general, right?
equals log base
Log base B of y.
b.
A.
Log base A of y has to be the same base. Then
X equals y.
then x must be equal to y if this is true. This is
Because of
true.
The 1 to 1
Because
to
it's
1 to
1
1
to
1
1.
to 1 property.
All right. And what we have for change of base?
log base A of x E is equivalent to log base B of X.
Do you know this? Why are you talking?
Cause he made a 6-7 joke.
Oh, I didn't.
He did.
Stop baiting people. Stop rage baiting people. Okay, Mr. Shadle.
Okay, Mr. Shadle.
What does this equal?
Log base B of X over log base B of A.
Right. That's change of base. And then we can write that in logs and ln's all we want. All right, so let's do some more properties. So this one, I'm going to call this the product property. And at this point, I will remind you of this.
Whoa.
With this in mind,
It's like the thing. In the thing.
with this in mind, I'm going to lay the product property on you. So in general, so log of some base of two things multiplied together is the log of the first thing plus the log of the second thing. And can we write this in natural logs and log base 10? Baron, can you give me the natural log for this version?
You wrote the wrong base for the second log.
Log base A. It's not log base B.
Or C.
Or F.
It's the same log.
For
Wait, I
Finn.
mean B.
Natural log UV.
Natural log
Or E. Or I.
of UV equals,
Natural log of U plus natural log of V.
and then Cormac, can you give me this in log base 10?
Log 10 of UV
Mm-hmm.
It's a new numbers.
equals, yeah,
It's a new
log U plus log V, or log 10U plus log 10V.
Yeah, if I just say log, that means log 10.
Okay, then just log U plus log V.
That's crazy.
Yep. Mm-hmm. Yep, that's product property. What else do you think we're gonna have?
Probably
Division
wants to do
prop-
with
quotient property?
division.
Let's do quotient property.
Okay.
Right, so this is product, it means multiplication, quotient means division. So you're both right.
Wait, so everything in 5 point squared is about different property?
All right, so
Wait, is that a yes or no?
I mean that we're starting with that. What do you think the quotient property is going to look like? What should I write?
Log base A of U over V.
And what do we think it's going to be?
Log
Wait! Don't tell me. What do we tell? So, based on our sort of feeling or intuition and experience with exponents and logs, what do we think this is going to say? Can you just write this down without me giving it to you? Can you just write it down? What do you think it's going to be? It's okay if you don't know it. Just what do you think? You.
Oh, that doesn't make sense.
No, because this one didn't turn into multiplication. So if that division turns into this
Oh,
division, it would
log
make
base
sense. If this multiplication turned into multiplication, it would
Right.
Oh, wait.
Ah.
Shit,
base
shit,
10
shit.
would be equivalent
That's one
to
big fat sign.
1.
Okay, wait, I
What do you think?
And then 0 would be equivalent to X. Oh, right.
And then
Mm-mm.
is it
Mr.
log
Shadow.
This
A
did that.
equals X? Or
Oh,
Wait, that's
well,
still- you wrote that
that'd
as
be
multiplication.
log 1 equals 0, then log 10
Oh, shoot.
equals 1.
okay.
Should check it.
Okay, so log 10 equals 0 and then
No, log 1 equals 0.
and then
Would
Log
it be,
10 equals 1.
would they multiply?
Thank you.
Wait.
So So maybe your intuition wants you to say that log of u times v is log of u times log of v. That would be a nice pattern if it did that, but that's not how it works. It's kind of the same way that this doesn't work. Log to the a over log to the b is not log to the a divided by b. I mean x to the a over x to the b is not x to the a divided by b, it's x to the a minus b. So in a similar way, this multiplication does not become multiplication here. This division here doesn't become division, it becomes what? Yep.
What?
Yup. So I have log base a of u minus log base a of v. And can I write these in natural logs and log base 10s? Cormac, give me one.
ln u over v equals ln u minus ln v. Ooh, I'm so smart.
Yeah, bro.
Good job, Cormac.
Patrick, give me one.
Log u over v equals log u minus log v.
Wow.
Okay, so I have another property that I want to give you, but I think you already know what it is.
Yes.
I think you can get it for yourself. So I'm gonna say, like log base a of u times u times u,
No.
What does that mean?
Is
YouTube
equivalent
helps
to
me.
log a u times log a 3.
or log base a of u cubed,
Yeah.
or log base a of u to the n. So these are by stages. You should be able to figure out your own property here. This is going to be called quotient property.
Wait, I thought the last one was quotient.
Oh yeah, sorry. This is power property.
Oh yeah, this is easy.
So you figure out your own power property based on this. So you fill in all three of these for me. You fill in this, you fill in this, you fill in this. Let me see what you come up with.
Wait, oh shoot, I'm writing it wrong.
I want you to do all three. No.
Okay.
No.
Okay.
Develop your own thinking. So pretend power property doesn't work, and just use your prior knowledge up here
What I was doing.
to come up with an answer based on having three U's written this way.
That's what I.
What about having three U's written this
I
way?
intuited
What
the
about
first-
having an arbitrary number of U's written that way?
I interpreted it with the first.
No, I want three answers. I very carefully drew three orange rectangles. Do you know the time and effort that I put into making those three orange rectangles?
No.
That's power property right there.
I'm still trying to figure it out.
So based on this, so you already know how to handle, like, can you handle u times, like, the only other intermediate step I can give you is turning uv into uu. So if you're not there yet, add one more
It's not u right there.
one more lap right here.
X becomes coefficient.
Yeah, I got it.
So do you know how to handle log base a of u times v?
Yes.
What is it?
Log base a of u plus log base a of v.
Okay, so as a another preliminary step, I'm going to say log a of u times u. Instead of u times v, give me log base a of u times u. Based on this, based on your prior knowledge, give me an expression for log base a of u times u. Can you use this to directly give me an answer for this? Yes? Okay, let's have it.
Log base a of u times log base a of u.
Is this rule give me a times here?
No, it's plus.
Plus
So
what?
Plus log base a of u.
And then so if I simplify this, what do I get?
Log u plus log
2
u.
log base a of u.
Matt, what do I get when I simplify this?
2 log base a of u.
2 log base a of u. Okay, can you do this one? Next one?
The same thing but 3 times.
So it's going to be 3 what?
3 log base a of u.
Log base a of u. And then what's Baron, what's the next one?
3 log a of u.
It's also going to be 3 log a of u. It's equivalent, right? These two things are equivalent to each other.
Mm-hmm.
And then
And log base a of u.
n log base a of u. This is my final form of my.
There are too many letters going on here, and I'll see the numbers.
But I write it in general. That way, if I say log base 3 of 4 to the 102nd power,
Oh my god.
So
what is that?
102 log base 3 of 4.
102 log base 3 of 4.
That's so much easier too than log base 3 of 4 to the 102.
Yeah.
Probably far past the integer limit.
Yeah.
in most calculators.
It's probably past my personal integer limit as well. Okay, so let me give you a trick question.
Oh, Lord,
We
Lord.
can about all the
Let me give you a
functions.
tricky question. Yeah.
Major issue.
What does the comma mean?
1,348.2. Can you answer this question first before you go to the restroom?
Before you can permiso el baño.
Marisa El Cinco.
El cinco.
Oh wait, I think I got it.
Don't say that loud.
I won't.
What is it?
Scream at the top of your lungs so no one hears it.
Yes! I finally got some.
1,348.2 log base 2 of 2.
Ha! Finally got something right.
Is that the answer?
No.
2. That's the
It's a trick question. I told you it's a trick question. This
Oh.
is a trick question.
I just reread it.
It's a trick question. So you might be tempted to say 1,348.2 log base 2 of 2.
Wait.
Is it equal?
Nah.
Or does it
However,
just
we
equal
got those rules from earlier.
1,348.2?
Where did my log rules? Log A.
Is this my final answer? Is this my simplified answer?
No,
Or
it's just one.
Cormac laid-
1,348.
Cormac
Yo,
laid
you
on me.
little rascal, Jason. I was gonna say that. I checked my log rules and I was like, whoa. If you look at it, it does the cancel thing.
Yeah.
And so it's just
Log-
1348.2.
Yeah, log to the base of 2
What?
each one.
1,348.2. Because this canceled, right? This became 1. Is there a different way that I could go directly from here to here to here?
Yes.
What?
Log base.
What's it called?
It is called the log base a of a to the
Log
something or other.
properties.
Yeah. Huh?
Wait, that's the one
Properties
I
of
The
log
funny
properties.
property.
Maybe inverse property.
bet.
Inverse property of logs. So I can, before I even start working, I can cancel this, and I can immediately write my answer. Either way.
Wait, but isn't like first going to like calculate the part, like the exponent part, like the 2 to the power of 1,348.2? Is then that we are going to calculate that part first.
I beg your pardon?
I think math is
I don't know how to describe it.
EP.
Well, never mind. I don't say it right now.
I think math's a little bit EP right now.
A calculator. What? Predicted you.
Did you predict what I was gonna write?
I did.
Mr. Show, what is the third word?
Exact.
I would really love to use a calculator.
Without.
Out.
So let's do log base 5 of the third root of 5.
I know this one.
What?
You do it. You do it.
Mr. Shittle.
Based on your expertise of logs and exponents.
Boom.
No.
No. Thanks.
Don't guess.
No, this is an educated answer.
23.
Don't guess.
No, it is not.
No, it's 142.
Don't guess. Don't say out your. Don't shout out your answer.
Wait, it's 142?
Don't shout out your answer. Work on it yourself.
I
Find
didn't
it.
get
I don't.
anything.
I don't care about the answer. I care about if you can find the. If you can use the process to find the answer. I care about the answer a little bit. Yes.
Yay.
Don't tell Matt.
I'm not gonna tell you Matt.
Nope.
Wait a minute.
Wait.
I can discern. I can discern something, not into that.
Wait, but how do you do this?
Mr. Shadle? Yeah, it's how's it work? Turn. We've done this a lot. I realize this. The log to exponent. What's that thing? What's the?
Oh wait, I think I
Like
know.
the log is like a.
Did you break your finger?
Like yeah, kind of.
You sprained it.
I sprained the
Yeah, it looks
yeah,
kinda
silly. AX.
You know how many cents that is?
Is that X or is this X? AX equals.
Insane.
Oh no.
Seven,
Mr.
seven,
Shayla,
seven,
no,
seven,
turn them
seven,
into each
seven.
other. Good.
So when you're working problems like this, I'm really interested. When you're working problems like this, I'm really interested in expressing things in terms of my original base. See if I can do that.
The answer.
I don't know the answer, but I got the first step, I think.
Okay, what do you like for the first step?
The
Is
answer
it
is
log
6.
5, log base 5, 1 over 5 cubed? Possibly?
Well, log base 5 of, I like that so far.
1 over 5 cubed.
Where does 1 over 5, so are we taking this?
Uh-huh.
So the cube root of 5 somehow is 1 over 5 cubed?
I'm not sure.
What is 1 over 5 cubed I'm only asking Matt. If I flip this out of the denominator, how can I write this without having anything in the denominator?
That's 5 to the negative third.
5 to the negative 3, I flipped the sign. That's not 1/3.
Oh.
So this is not equal to 5, this is not equal to 1 over 5 cubed.
Oh.
What's another way of writing square root of x?
1 over x.
It's not 1 over x.
Max, you sometimes amaze me, but not like.
Finn, do not make comments.
I'm sorry. That was uncalled for.
What's the magical equivalence of square root?
X to the negative first.
No, that is x. That is 1 over x. I flip this sign, and this is an implied x to the 1, right? So I flip it. I flip the sign,
Oh.
and then I can write it without it being in the
X to the
denominator.
negative 2.
X to the negative 2 is
This is so.
somebody remind me what square root
X
means.
to the power of 1/2.
So square root of x is equivalent x to the 1/2
Uh.
power. The cube root of x is equivalent to x to the what?
1/3.
go.
Okay, somebody else tell me x to the 4th is
1/4.
equivalent to x to the 1/4. What is x to the 6th raised to the what is the 5th root of x to the 6th?
6/5.
No. X to the 6/5. Shit, that was not sad.
What is the 7th root
Sorry, bro.
of x to the 6th?
No.
6
Mr.
over
Shade
76.
Ah, rage bait.
7/6.
The reciprocal.
No, it's an
of
exponent.
6.
6
Oh,
over
yeah,
7.
You're right, Brad. My bad, Mr. Shit.
So what is this? What is this equivalent to, Matt?
That would be log base 5 of 5 to the 1/3.
Let's go.
Okay, and then I don't know what's
Oh, yeah, that makes
Don't
sense.
you? Don't you
Oh,
know?
5s cancel, and then 1/3.
The
The log base 5.
log base 5 of 5 to the something cancels, leaving what?
That's
1/3.
1/3 is one way to solve it.
Oh my
The other way
God.
to solve it is just to bring down the exponent. What's using power rule? What's the first step to solve this?
I have no idea.
We're going to convert it into exponential form? Or is it just
Multiply.
Exponent comes down in front.
Log
Yeah.
5.
Exponent comes down in front.
5 of 5.
Log base 5 of 5, but log base 5 of 5 is what?
1?
Is 1.
I feel
So
like the
you-
first one is actually much easier.
It is easier. So if you can see this and cancel it first, it's easier. But even if you don't, then you should reduce this to 1 at the end.
She's one of the college counseling people, I think.
All right. I want you to expand
Oh no. Wait, we should do another one like the one that we just
each
did. Please?
log expression. All right, you want to do another one?
Yeah, like the one that we just did.
Okay. No, we're not going to expand yet.
That seems really
We're
complicated.
going to expand our minds later. All right. So this is find the exact value without using a calculator. Let's see. I got to upgrade my handwriting.
You got an Apple Pen.
Did you buy a new one? You did?
I had a sharp stabbing pain. I'm so sorry.
You're good.
Oh.
Cormac. I almost called you Corker.
Corporate.
What is it? Oh god.
Do not count it out. Do not call it out. Do not answer out loud. Just write it down.
Wait. Might be smart.
Oh, I'm so low. Write it down, Matt. Follow instructions.
If it's not this answer, I don't know what to do.
Aha. I get you?
Yeah.
Ooh, I'm feeling so smart, dude. I'm on a roll today. I'm just like zinging, dude. I'm like, can't explain it.
Yep.
Mr. Shavle, would you like to see my paper?
Yeah. Let me squeeze. Beep beep.
Then it's incorrect.
I see.
You little fucker.
No?
Oh, I see.
Yeah.
Yeah. That's smart. Thank you,
Hey,
dude.
hey,
Did you
Finn.
write it down though?
Ben, sometimes I'm
It's not gonna do you any good if you don't write it down. Just give me the
Well, I
answer.
just wanted to give you the answer. I've been married a long time ago.
Did you get there?
Yeah.
What'd you end up with?
4.
So you could solve this way. Do you agree?
Yeah.
Yeah, that's really hard.
Yeah, I sold
And then what? E to the 6 over e squared is what?
E4.
And then we get e log e to the 4, and then that is what?
4.
It's 4. Right. All right. Okay, now we're going to expand our
Oh.
minds.
I feel like if my
I'm
brain
still not
expands
right
even more, it'll snap.
there. Yeah, dude.
We're going to expand each expression.
How do you expand?
So maybe I'll give you an example, and then I'll have you do one.
Yeah. please
So let's
expand.
do the first one as log base 4 of 5x cubed times y. So what we're imagining is I have a computer that can calculate logs, but it can't calculate complicated expressions. So I can feed it as many logs as I want, and it'll be really fast and render my video game and make it the most playable, fun video game ever. But I can't send it a complicated expression like this. So expand means take this complicated expression and make it as many log expressions as you need of little things. So
Is that what this chapter is about?
that's
Or this unit?
no.
Oh.
Why are we
No, I'm
asking these
just
questions?
I'm just confused because we learned so much about like the things of logs and the properties. I'm just wondering what we'll use that for.
So I mean logs and exponents are super foundational and useful for everything that you're going to do in math after this.
Oh,
Let's just say that.
it's not just a
So
chapter.
what can I do to expand this a little bit or a lot of it? How can I expand this? I don't want to take one log of a complicated expression.
You can take it into log base 4 of 5x cubed times log base 4 of y.
No, would
Is
it
that
be
how that
plus
works?
log base 4 of
Is
y?
that how it works?
Plus, right?
Do I have a property that takes my log of a product and turns it into a product of logs?
Yes.
No.
I said
absolutely
plus.
not.
You did say plus?
Yes.
Oh my goodness.
Good.
Oh,
Don't
that
think
makes
you
so
did.
much sense.
Okay, is there anything else I can do?
You were
Yes, you can then split up the log base 4 of 5x cubed into log base 4 of 5 plus log base 3 log base 4 of x.
I'm gonna do the first thing you said, and then we'll do that in the next step.
Right.
Log base 4 of x cubed, and then I still have a log base 4 of y.
How did what?
So these are multiplied together, right?
I don't know, man.
Is this 5 times x cubed?
Yes.
So this is like log base a of uv. Matt, what is log base a of uv?
Log base A of U plus log base A of V.
And so if I have log base 4 of 5 times x cubed, which one is u? First of all, which one is a?
A is 5.
Nope.
A is X.
It's 4.
A is 4.
A is the base.
Oh yeah.
A is 4, u is what?
U is 5. V is X cubed.
V is x cubed. And so what does this expand out to using the product property? The product property, yes.
Oh, log base 4 of 5 plus everything that you had down there.
Yeah, all this stuff, right?
Yeah.
I'm taking this expression and I'm breaking it up into these two things. All right, and then Baron, what can I do after this?
After that, I would take log base 4 of 5 and solve it, and then add, so like find what that equals, and then I would do plus log base 4 x cubed, or 3 log
Once
base
you're-
4 x plus log.
Once
Right,
you
so-
figure it out,
yeah.
there's one more thing we can do.
If you put you can take the 3 and put it in front, and then
Yes.
you can add log base 4 of y.
Yep. So, and I don't have to solve this. So for this kind of expand the expression thing, I don't really need to solve it. If I ever came out with a log base 4 of 4, or log base 4 of 16, or a log base 4 of 1/2, maybe I could simplify it.
No, we're not getting.
Can we
to that.
Can we simplify these?
First
Yeah.
one's 1.
The first one is 1.
The second one is
One is 4.
No, 2. Just 2.
4 to the 4 is 16? Question mark.
Sorry, 2. Yeah.
No,
4 to
4
the
to the 4 is
2.
not 16.
Yeah.
Wait, how do we know it's 2? What? I'm
So
negative?
so for this kind of thing,
Four
let's.
to the two.
All right. Instead of doing this in our head, we're
Well,
going to
base
Finn.
four
Let
is
me
four to
answer
the
his
two.
question. Finn. Let me answer his question.
Sorry.
So I'm gonna express this in terms of the base, because I'm all about that base. You got it. How do I express this in terms of base 4? I'm just gonna rewrite it here. Log base 4 of, how do I express this part in terms of something that's base 4?
4 up 2 squared.
4 squared is the same as 16, right?
Yeah.
And I picked 4 because that was my base,
Oh, and then they cancel.
and then that's 2, right?
Oh, so it's all about.
So let's do this one.
Wait, what?
Yeah, so that's the rabbit hole I'm going down right now. Is log base 4 of 5? I can't simplify it. I'm just going to have to resort to my calculator. But if it were a power of 4, then I could simplify it by hand.
So what about the first one? So then it's log base 4 of 2 squared.
No, you wouldn't want to do 2
No.
squared. You want it to be in.
What first one? This one?
Yeah.
This one?
It's just log base 4.
No, I don't want base 2. I want base 4.
Because it's already.
Right.
For that last one, it's log base 4 of 2, 4 to the negative 2.
I don't think that's right. It's like a negative square.
Mr.
Yeah.
Shadle, it's log 4.
So I can expand this. I can expand this by hand.
It's log 4 of 4 to the negative 1/2,
So
and therefore.
yeah,
is
the
equal
fact
to-
that you could do that in your head doesn't really help people as much as doing it methodically. So can I express this in terms of something that includes a 4?
2 over 4.
What about square root of 4?
Yeah.
Is that an easy way of expressing this in something that includes a 4? What?
Yeah.
Can't you also just change it to natural log of 4 over natural log of 5?
Which?
Log 4 or 5? Or base
For
4 or 5?
negative 1 over 2.
I'm sorry, I'm not following what you're asking.
For log base 4 or 5, you could do instead natural log 4 divided by natural log 5.
Yeah, so again, on this kind of expand each expression, unless I have a chance to simplify it, I'm just going to leave, what I'm saying is I'm just going to leave this alone. But because this is how my brain works, I thought, well, maybe if that's a 4, or maybe that's a 64, or maybe that's a 1/2, then maybe we could simplify it. So we're just taking a minute to figure out any powers of 4 we can simplify because it's base 4.
Would you accept
5 is not a
natural log-
base, is not a power of 4.
Would you accept natural log 4 divided by natural log 5 on a test? Because
It's not natural. What did you mean to say? Because this is not natural log 4 divided by natural log 5.
well, on the properties we learned that if you have like base b, so log a of x, or like log 4, like a being 4, x being 5, you could change that to log x over log a, and then you could change log 5 over log 4. But
So I would not want to see log 5 over log 4,
or
ln
natural log
5,
5
or ln 4, because I'm asking you to expand this. So if you think of expanding it, leave the base alone. Leave the log base alone, and expand all this stuff, and you can use as many log expressions as you want to expand it fully.
So like after expansion, we do simplify all the stuff with expand.
You can simplify it. So
But do we need to figure out the final value?
no, I'm saying leave it expanded. Nice.
See if it wakes me up.
Huh?
See if it helps me stay awake.
There's not much more to say.
Can I finish expanding this?
I don't know.
How do I simplify this?
Oh. 1/2. What?
Yeah, next to Jason's question.
I
Is that what you said, Finn?
Yeah,
How'd you get
negative 1/2.
How'd you get negative 1/2?
Because
But square root of 4 is 2, so 1/2.
Yeah, but that's what we
Square
were
root of 4?
simplifying.
yeah,
Or
so
we
one-
can do that.
No, I'm
half.
I'm deliberately making it something in terms of 4.
Oh. But, so then how would, like, you could also do log of 4 and then to the 1/2?
So yeah, it's the same as
I don't
as
get it.
You might not
1/2.
see this in terms of
1/2
this
is
kind of
equal to
question.
4 to the negative 1/2.
I doubt this kind of question is going to have something that you can simplify. But if they say what is log base 9 of 1/81, I hope that you can solve that.
Yeah, that's
What's log
Yeah,
base?
so it's
Log base 9 of
1/9 squared.
1/9 squared.
1/9 squared, and that is log base 9 of
9 to the negative second.
which is.
-2.
Let's go. All right, we're out of time. Good job, thank you.
Arigato, Mr. Shadle.
Huh?
Arigato, Mr. Shadle.
I don't know how to say you're welcome in Japanese.
Dude,
Arigato
Nada.
Arigatou gozaimasu. Sumimasen.
Arigatou gozaimasu.
Dostashimashite.
What'd you say, bro?
Wait, do you have one today?
No, it's
So,
Friday.
let's see.
Yeah, I didn't say it.
Our whole